Hi, this is SMS and this is question number 6 of June 19 paper 1R. This question is from the chapter Arithmetic Progression. And question A begins by saying that show that the sigma notation of 4R minus 3 is equals to n bracket 2n minus 1. So the summation, this sigma notation, this actually means the summation of all the terms from the first term to the nth term. Okay, so the sigma notation is usually it's actually a shortcut way of writing the summation of the terms from the first term to the nth term. Okay, to the nth term, the nth term could be the 10th term or the 11th term or the 100th term. It could be anything. So for part A, the sigma notation, for n, and we are given r equals to 1, and this is 4r minus 3. Okay, and now the usual way of writing the sigma notation is this. Okay, so the usual way of writing sigma notation is r equals to 1 un. So this means that the nth term, the expression of the nth term of a sequence is given by un. Okay, the expression for the nth term of a sequence is given by un, and now this un can be for an arithmetic progression or a geometric progression. Okay, the difference between them is that arithmetic progression, each term has a common difference between them, while in arithmetic and geometric progression or a geometric sequence, each term is separated by a common ratio. Okay, so when I say it, for example, when in arithmetic progression you have a common difference, it means that the difference between the second term and the first term will be equal to the difference between the third term and the second term. So the difference between each consecutive terms is same for an arithmetic progression. So, for example, here, if you look at it, a T1 is given to be T1 is given to be 4 bracket 1 minus 3. The first term is actually just 1. 4 minus 3 is 1. Now T2 is given to be 4 multiplied by 2 minus 3. So this is 8 minus 3, which is 5. Now T3 is given to be 4 multiplied by 3 minus 3. So it's 12 minus 3, which is 9. So if you see, the difference between the second term and the first term is equals to the difference between the third term and the second term, which is 4. So 9 minus 5 is 4, 5 minus 1 is 4. So there is a common difference between them. So I can say that un, the sum of the first, this sigma notation or this summation is for an arithmetic progression. Okay, and that is the first thing that you should be doing when something is given in a sigma notation. You first have to identify whether the given expression is for an arithmetic progression or a geometric progression. Okay. I will explain how to understand whether it's a geometric progression in another video, but you have to identify that at first, either by identifying a common difference, what we did here, or by identifying a common ratio. If there is a common ratio, then that's the un given is for geometric progression. Now we know The sigma notation, as I've firstly mentioned, is a shortcut way of writing the summation of the terms. So here, the question is asking to us to find the sum of all the values, sum of all the terms from the first term to the nth term, right? And the first term we know is 1, right? We got t1 to be 1, and this is actually denoted with a. We denote the first term with a, and the common difference with d in an arithmetic progression. And the summation of the first n terms, the sum of the series is given by Sn is equals to n by 2 bracket 2a plus d multiplied by n minus 1. Okay, and this is a formula that will be given in the formula sheet at the beginning of the question paper. But this formula is used to find the sum of the first n terms of an arithmetic sequence. Okay, if the n is 100, so the summation of the 100 terms is found by this n by 2 multiplied by 2a plus d n minus 1. Now here we don't know. Here the question is asking us to find the summation of the n terms. Okay, the n terms. They did not mention the integer value of n. They said that the summation of the n terms. So s n, I leave n as it is, n by 2. We know 2a, so a is 1. We got it from here, the first term. A is just the first term. So 2 multiplied by 1 is just 2 plus the common difference. Here the common difference is what? 4, right? We found that the difference between the second and the first term is 4, and the difference between the third and the second term is also 4. So we can say d is 4, n minus 1. N is just n, as we are trying to find the summation of the n terms. Now Sn is given by n by 2 bracket 2 plus 4n minus 4. Now Sn, the summation of the n terms is given by n by 2, 4n minus 2. So Sn is n by 2. Now if I take the 2 common, so this is 2n minus 1. So this 2 cancels each other out. And now we are left with Sn to be n multiplied by 2n minus 1. Okay? So this is Sn, and this is what they have asked us to show as well for the first part of the question. Now, hence or otherwise, find the least value of n such that this is greater than 1000. Though this part is greater than 1000, the summation of the n number of terms is greater than 1000. So when I sum, for example, n number of terms, the summation must be greater than 1000. Okay, so the way I usually solve this question is, you have to remember one thing, that n cannot be a decimal value. N cannot be a decimal value, and n cannot be a negative value. Okay, these two things that you must remember for solving questions of APGP. Okay, that n cannot be in decimals and n cannot be in a negative value. So here what I will be trying to find is that what will be the or to simply put, what will be the value of n for which the summation of the n number of terms will be equivalent to 1000. So what I'm trying to find is this n. At first I will find this n, so I will try to find how many terms are required, uh, how many terms, which is n, are required for Sn to be 1000, for the summation of those terms to be equivalent to 1000. So how many terms are required? So we want to find that. For that, at first I will be equating Sn is equals to 1000, right? Sn is equals to 1000. Now Sn we got was n bracket 2n minus 1 equals to 1000. Now 2n square minus n is equals to 1000. So 2n square minus n minus 1000 is equal to 0. Now if you look at this, this is in the form of ax square plus bx plus c is equals to 0, where a is equals to 2, b is equals to negative 1, c is equals to negative 1000, and here we are substituting x with n. So the quadratic formula for ax square plus bx plus c is given to be x equals to minus b plus minus b square minus 4ac divided by 2a, right? And now instead of x I write n, so n would be just, instead of b I will be writing negative 1 plus minus negative 1 square minus 4ac is 2, c is negative 1000 divided by 2a, so a is just 2. Okay, so n would be 22.61. If you put that in your calculator, you'll get this value. And as I mentioned, n for our cases here will always be an integer value. And so the next for n to be this, the least value of n, such that this is greater than 1000. So if n is 22.61, if 22.61 number of terms, which is not viable but is actually added together, then the summation of those terms would be equivalent to 1000. So the least value of n for which Sn will be greater than 1000, and to remember n is an integer, so n would be 23, right? Because we need Sn to be greater than 1000. They did not ask us to find the value, to find Sn for which to find the value of n for which Sn would be 1000. They have asked us to find the value of n, the least value of n for which the summation is greater than 1000. So here the summation of the 20 of the first 23 terms will actually be equivalent or will be greater than 1000. If you sum, for example, the first 22 terms, the value of Sn will be less than 1000, right? But if you sum the 23 terms, then Sn will be greater than 1000. So as I mentioned, n will be an integer, so this would be n would be equals to 23, the least value of n. And now another thing, you will also get a negative value here. Obviously you will get a negative value here because this is a quadratic formula and n cannot be negative. So you don't say the negative 7th term of a series, right? You don't say the 22.78 term of the series. We don't say that. We say that the second term of a series. We say the 20th term of the series or the 50th term of the series. We don't say 50.5 like term of the series. It doesn't make sense. So that's the thing that I'm trying to explain here. Okay. And now for part C, okay, for just for clarification, for Sn to be greater than 1000. For part C, they have given Sn, which actually we showed in part A, and Tn to be 4n minus 3, and that 18 plus 3 Tn plus 7 is equivalent to Sn plus 4. Okay, so at first let us just write Sn. Okay, this might be confusing, but it's a very simple thing. So n bracket 2n minus 1, and Tn they have given us, which is 4n minus 3. So 4n minus 3. So Sn they have actually access to find Sn plus 4 and Tn plus 7. So Tn plus 7, so Sn plus 4, let's do that, Sn plus 4. We just substitute here n with n plus 4. Okay, substitute that. So here this would be simply n plus 4 bracket 2 n plus 4 minus 1. And for Tn, okay, let's just write this a bit to the right hand side. So Tn would be 4n minus 3, right? Similar thing, they have access to find, I think, Tn plus 7. So Tn plus 7 would be 4n plus 7 minus 3. So right now they have given this expression as well. 18 plus 3 and plus 7 is equals to this. We need to find the value of n. So 18 plus 3 t n plus 7. So let's write that given is that 18 plus 3 t n plus 7 is equivalent to s n plus 4. Right now substitute 3, 18 plus 3 n plus 7. So n plus 7 is 4 bracket n plus 7 plus 3. Sorry, minus 3. Sorry, minus 3 is equals to Sn plus 4. Sn plus 4 n bracket 2n minus 1. Okay, now 18 plus 3. Let's leave the 3 as it is for now, and then this will be 4n plus 28 minus 3 is equals to 2n square. Sorry, this is Sn plus 4. So Sn plus 4 would be, it's my mistake, so this would be n plus 4, 2n plus 4 minus 1. Okay, so then this should be, simplify this, so n plus 4, and this is 2n plus 8 minus 1, so this would be plus 7. So what I did here is 2 multiplied by 4 is 8, and there is a minus 1 after them, so 8 minus 1 is 7. Next, 18 plus 3, 4n plus 25 is equals to 2n square. So n multiplied by 2n is 2n square plus n multiplied by 7 is 7n plus 4 multiplied by 2n is 8n plus 7 4s are 28, right? Now, so 18 plus 12n plus 25 multiplied by 3 is 75 is equals to 2n square plus 15n plus 28, right? Now, let's take everything to the right hand side, because there is a 2n squared there, so it's better. So let's leave 2n squared as it is in the right hand side. Now we have 15n, and now we'll take the 12n to the right hand side, so this becomes negative 12n plus 28 minus 18 minus 75. Okay, and then if you do solve for all this, then if you simplify all this, sorry, then you will get 2n squared plus 3n minus 65 is equals to 0. So now, using the quadratic formula as I used in part B, so here a is equals to, so this is the thing, so ax squared plus bx plus c is equals to 0. The quadratic formula is negative b plus minus b square minus 4ac divided by 2a, right? Here b in our case is 3, a is 2, and c is negative 65. So the similar thing I will do is minus 3 plus minus b square, so 3 square minus 4ac, a is 2, c is negative 65 divided by 2a, so 2 2s are 4. So n would be equals to, if you put all this in your calculator, then n you will get two values of 5 comma negative 6.5, and as I mentioned, n cannot be negative, n cannot be negative, so n is equals to 5. So that's it for this question. I hope you guys understood it. If you have any queries, leave down in the comments. Thank you.